Now in MLR, we have more than one variable. So it is important that we know that which variables are relevant and which are not. Accordingly, we will include only those variables that are relevant to our model. This process is called variable selection. Now there are multiple ways to select the right set of variables for the model. First among them would be business understanding and domain knowledge. For instance, while predicting sales, we know that marketing efforts should impact positively towards sales, and it is an important feature in your model. So business understanding, domain knowledge will always play an important role in data science. We have to use both our tools as well as experts' opinion. Another way is that we start with 0 variables and keep on adding and try all different combinations of variables. And then we have metrics like MelOCP, AIC, BIC, adjusted R-square, or plot of residuals to select the best model. But the problem with this approach is that we will have to build models from 0 variables up to p variables, which is like 2 raised to the power p combinations, and that would be too many models. So this is not the best and efficient approach. So let's see what are the other techniques that we can use for variable selection. Now there are many techniques for reducing the variables. All of these techniques can be applied to a variety of algorithms. So we will see the first 3 techniques: forward selection, backward selection, and mixed selections here in this video of linear regression. Then ridge regression and lasso regression are also called as regularization techniques that we will see when we will do logistic regression. Then we have dimension reduction techniques like principal component analysis, factor analysis, etc. We will see principal component analysis in the next module, that is advanced modeling. Then there are a few other optimization techniques such as genetic algorithm, ant colony optimization, and various other techniques are there. Now we will not be looking into all of these techniques. We will restrict ourselves to 6 methods that are more than enough for us to learn. So let's start with our first method, that is forward selection. So in forward selection, as you can see on the right hand side, we start with the null model that has no variables. Then we create models with single variable and select the model with lowest RSS. Now search through the remaining variables and select which variable to be added based on RSS. And then we'll create another model and add another variable based on RSS, and so on. This process will continue until some stopping criteria is obtained. Now the stopping criteria could be user defined, such as when all variables selected has a p-value less than a certain value, or it could be something else. Now there is a drawback of this method, that is it may include variables in the early steps that later becomes redundant. That is why it is also called a greedy approach. Then the next method is backward selection. Here we start by including all the variables as shown here in the image on the right hand side. Then we start removing variables with the largest p-value, that means which are least significant. And then we continue this process until some stopping criteria is obtained. Now the drawback of this method is that it cannot be used when p is greater than n, means the number of variables are more than the number of observations. Then the third method is mixed selection. Now as the name suggests, it is a combination of backward and forward selection method. So here we start with no variable in the model as shown here in the image, and then add new variables to it. And then at any point, if p-value of any variable crosses the threshold which is defined by the user, then the variable is dropped. So we continue these steps until all the variables have a p-value below a certain value. Now mixed selection addresses the drawbacks of both of our earlier methods. Hence it could be considered a better approach.